Welcome. In this lecture we're going to talk about the vector cross product. We have already seen a vector product, and that was with work. And we multiplied force times displacement, those two vectors together, and we got a scalar out of it, a quantity we called work. And this time we have a couple different quantities that we get a vector cross product for. And when you multiply two vectors using a cross product, you get a vector, a third vector. So we've already seen this, and I've already mentioned it with torque. So here we have a particle in XYZ space sitting right there, and it is some distance r away from a chosen origin, and it's got a random force acting at it at some angle phi. And we've already seen that there's two components to this force. We've got the one component that is parallel to the r vector, and we have the other component that is perpendicular to the r vector. And it's only that perpendicular vector, or that perpendicular component that causes a torque on the object. And so we know that then torque is equal to that perpendicular component, which is F sine theta, sine phi, times r, the distance from the origin at which it's applied. Now this is actually technically a vector product, and so we should get a vector as a result. And this diagram right here shows which direction that torque vector is going. And we talked about using the right-hand rule. So more technically here, torque is really the vector cross product of F and R. So to get the direction, we talked about using the right-hand rule. So here is our F vector again right there, and we curl the fingers of our right hand from F towards R in that direction. And what we see here is if R and F are in the xy plane, which they are, then we get our torque vector going out here in the k direction, k hat. So we point our thumb, after we curl our fingers from F to R, we point our thumb, and our thumb gives the direction of that. And in this case, it would be coming out of the screen right at you. So here's the cross product a little bit more generally. We have vector A and we have vector B. And vector A and B make their own plane. They are coplanar. And when we take the cross product, and this is specifically A cross B, it makes a third vector C. And vector C is orthogonal to both vector A and vector B. So it is perpendicular to the plane that A and B make. And we need to be very specific here with the right-hand rule, because when we do A cross B, we have to curl our fingers in the direction from A to B, as this diagram right here points out. So if it's A cross B, we curl from A towards B, and our thumb points in the direction of the resultant vector. Notice that if we do B cross A, we do not get the same vector. Try it yourself. Curl your fingers from B to A. This way, your thumb is going to point down. So B cross A is going to be down here. And it's going to be equal in magnitude because it's still going to be the magnitude of B times the magnitude of A times the sine of the angle between them. But our thumb is going to point downward. So that leads to the fact that A cross B is equal to the opposite of B cross A. So that property is different from the dot product. A dot B is equal to B dot A, but it's not true for the cross product. So here, let's look at this picture again, and let's replace A, B, and C with our unit vectors. So let's call A I hat, let's call B J hat, and let's call C K hat. And this follows the rules of what's called a right-hand coordinate system. And in a right-hand coordinate system, I cross J will point in the direction of K. So we've got I cross J points in the direction of K. What if we crossed J and K? So take your fingers and curl from J up to K. We get a vector that points out of the screen at you. That is in the I direction. So J cross K then will give you a vector in the I direction. And let's see what we get when we cross k with I, if we do k cross I, so go down from k to I, we curl our fingers that direction, we get a vector going in the j direction. So k then cross I will give us a vector in the j direction. And from the previous screen, we saw that if we reverse the direction here, if we do I cross cross k instead, we'll get a vector going in the negative j direction. There's an easy way to remember this, and that's on this page. So start with I at the top and do ijk clockwise, then put a little x for cross product. So we get I cross j will give you a k. We get j cross k will give you an I, and we get k cross I will give you a j. So we go around the circle in that direction. All right, so again, it's I cross j gives us a k, and it's j cross k. If my pen will write, come on, you know you want to. Come on, you know you want to. Bring it, there it is. J cross k will give us an I, and k cross I will give us a j. All right, so when you're working on your homework, keep that in mind. Let's take a look at another example to illustrate a property of the cross product. Here we have vector A that's going in four units in the I hat direction. And let's draw a vector B. It's going in the same direction, but it's only 2 units long. And this is vector B. And we want to look at what is A cross B. And we can use the one formula for the cross product, which is going to be the magnitude of A times the magnitude of B times the sine of the angle between them. So the magnitude of A is 4, the magnitude of B is 2, and the sine of the angle between them is 0. Sine of 0 is 0, so A cross B is equal to 0. So this is a general property of the cross product. If we have any A I hat cross B I hat, if they're going in the same direction, it's always going to be 0. Let's look at a slightly more complex example. Here we have 2 vectors A and B, and A is going in the I direction, B is going in the J direction. So when we want to look at A cross B, we can again use the equation. It's the magnitude of A, 4, times the magnitude of B, which is 2, times the sine of the angle between them, which in this case is 90 degrees. Sine of 90 is 1, so we get a magnitude of 8 for A cross B, but remember we also have to give a direction here. So we use the right-hand rule. It's A cross B, so we curl our fingers from A to B. Our thumb points out of the board. That is the positive k hat direction. So this is positive 8 k hat. Notice that B cross A sets up the same way, and it's going to be 2 times 4 times the sine of 90, which still gives us a magnitude of 8, but now we curl our fingers from B to A, which is going to give our thumb pointing into the board, and that's in the negative k hat direction, so it's negative 8 k hat. So use AB sine phi to give you the magnitude, and then use the right-hand rule to give you the direction. And this will work if it is 4I cross 3K. All right, you're going to go A cross B, and that, or sorry, use the right-hand rule A cross B, and that's going to give you your magnitude. It'll give you your direction. Okay, let's look at our final example here, and we're going to illustrate the 2 different ways to find the cross product between 2 vectors. Just like with the dot product, we had 2 different ways. We had a way to use magnitude and direction of the 2 vectors, and then we also had a way to use the component form of the 2 vectors. So here we have 2 vectors, A and B, in component form, and we want to look at A cross B. So let's first look at magnitude and direction. If we're going to draw out vector A, he goes 4 units in the I direction and 1 unit in the J direction. 4, 1. Here is vector A. And we can find a magnitude for A. It's going to be the square root of 4 squared is 16 plus 1 is 17, so it's going to be root 17. And the angle here is going to be the inverse tangent of 1 over 4. And the inverse tangent of 1/4 is 14.0. degrees. For vector b over here, he goes 2 units in the I direction and then 3 units up in the j. So here's vector b, 2 and 3. So his magnitude is going to be 4 plus 9. Square root of 4 plus 9 is 13. And we have an angle here, the inverse tangent of 3 over 2, which my calculator tells me is 56.3. So if we're going to draw A and B together here, we've got vector A, we'll put in red. He's down here looking like that. There's vector A, and vector B is going to be up here, a little bit shorter, looking like that. And if we subtract the angle between them, 56.3 minus 14 is going to give us 42.3 between the two. So to find the cross product, A cross B, it's the magnitude of A, which was root 17, times the magnitude of B, which is root 13, times the sine of the angle between them, 42.3 degrees. So plugging that into the calculator, we get a nice, neat 10.0 units long, and now we have to give the direction. So again, we use the right-hand rule to give us the direction. We are going to curl our fingers from A to B, thumb points out of the board, so we're talking about positive k hat. So this is positive 10 k hat. Now let's take a look at how we would find this using the component form. So here we're going to use a kind of FOIL. We've got 4i plus j, and we're going to multiply that by 2i plus 3j. And just like when we FOIL binomials, we've got to do every term. So we're going to get 4i crossed with 2i plus 4i crossed with 3j plus j crossed with 2i plus j crossed with 3j. We need to be very specific about the order in which those are placed, because remember the property of cross products. The other property of cross products we have to remember is any I cross any other I, because the angle between them is 0, so this goes away, and we've got a j cross j over here that goes away. So we're left with 4i cross 3j plus j cross 2i. So here, for I cross j, we're just going to have 4 times 3. And that's the magnitude. The angle between them is 90 degrees. Sine of 90 is 1. So we got 4 times 3 plus, we have 1 times 2. Because again, j and I, the angle between them is 90 degrees. Sine of 90 is 1. So we get 4 times 3 is 12. Now we need to be careful about the direction here, because it's not just 4 times 3 and 1 times 2. There is a direction. So when we do I cross j, remember, here's I and here's j. We curl our fingers this way, our thumb points out of the board. So this is a positive 12 right here. But when we do the other way around, j cross I, curl our thumbs this way, we get a negative k. So that actually ends up being a negative in here. Negative k hat, and let's put a positive k hat. So we've got a positive 12 k hat here, minus 2 k hat here. 12 k hat minus 2 k hat gives us the answer we already got, 10 k hat. So those are the two ways of finding our cross product between two vectors. We won't get into three-dimensional cross products because we don't need it for our physics. So there it is. Your homework assignment for the weekend is as follows. All right, Chapter 10 problems 27, 29, and 31. They're quick, they're easy, enjoy those, and I'll see you guys in class.